Hello there, students. This is Miss Becky again. I'm going to be going over how to solve trig equations. Before I get into that, I wanted to remind you guys that the word inverse just means the opposite or the reverse of something else. And as you recall, we use inverse operations to kind of undo each other. So it's the undoing of these operations that help us to solve an equation. And a lot of times we've been solving for x, so we're just undoing everything that's been done to that x to come up with our solution. This time we're going to be solving trig functions or ratios. So we know that addition and subtraction are inverse. They undo each other. We know that multiplication and division undo each other also. So the thing that we're looking for now is, well, when we've been doing, like, say, the cosine of, let's see, 60 degrees. This is one thing that we've been working on. And let's see, we turn on our calculator and clear it out. So when we have done this, you guys have done, you've put in the cosine of 60 degrees and it spits out 0.5 or 1/2. And let's see, where's my pen? Oh, did I lose my pen? Pen, come back. Wait, I gotta find my pen. Okay, I found my pen. It lags a little bit here and there. So the cosine of a 60-degree angle is, lost my calculator there, 0.5, which is 1/2. I told the calculator to tell it to me as a ratio. And remember, these trig functions are ratios. So when we put in the cosine of a 60-degree angle, it gives you the adjacent leg over the hypotenuse. Right. Okay. So, but now what we're looking for is we're going to be looking for the angle. Okay. So if I type in the calculator, well, let's see, trying to get my calculator back. Sorry. Okay. If I type in second cosine, okay, if I know that the cosine I'm looking for is 1/2, so I'll just put in 0.5 because it's easier. Oops. And maybe I'll do it correctly. 0.5. And go over here. Okay, so what it should give me is that angle that I was looking for. So this little -1 that you see there, it's not an exponent, and it gets confused sometimes with an exponent, but on the calculator, it just simply means the inverse of cosine. So what we know undoes addition is subtraction, multiplication is division. What undoes cosine is what it's called. Let me write it over here. It's pronounced arc cosine. Okay, that's what that little -1 thing is called, arc cosine. And so if I multiply this side by the inverse of cosine, it cancels it out, takes it away. And so what I do on this side, I need to do on this side. So I multiplied that 0 by the arc cosine, or the inverse. It's no different than, we know that if I have, say, 4/5, and if I multiply that by its reciprocal, we know that multiplying fractions by their reciprocal cancels them out or undoes them, so it takes it away. Same deal with this. This arc sine is the inverse, so it undoes that cosine. What you do to one side, you have to do to the other side. So what that simply now gives us is the inverse of cosine of 0 will spit out the angle that we're looking for. Okay, so let's pull up our handy dandy calculator. Okay, let's clear it out just because. So now I'm going to put in second cosine, and notice it brings up the inverse. And the number that we have is 0, close a parenthesis, and it spits out 90 degrees. So it's a 90-degree angle. But on IXL here, they want it in the form of radians. So once again, you can, if you want to, take 90 degrees and multiply it by a radian like this. And this 90 cancels, well, this becomes 1, this becomes 2. And then as you multiply across, we have 1 times pi, which is pi. And the denominator, we just have 2. So the answer is pi over 2. So in degree form, it would have been 90, but they're telling you where they want that answer, and it's pi over 2. Now, it had said that the answer needs to be between pi over 2 or a negative pi over 2, so, or half of a pi. So positive half of a pi is going to be up here at 90 degrees. But if you're starting here at 0 degrees and you're going a negative 90 degrees, it would be not 1.5 or 3/2 pi. In the negative direction, it would be a negative pi over 2. All right, now the next one is asking for the sine of theta. The sine of some unknown angle is 0. Now, we don't have to do all of this. We're looking for an angle, so simply bring up your calculator. And so we're looking for the angle, so we're going to do the inverse of sine, and the number that they gave us is 0, and you press enter, and that's also 0. So the answer for that one, so when we did this, it equals 0, and which is fine because they want it in the degree form, so we don't need to put it into any type of radian or anything like that. Okay, moving right along. Sorry, I'm a little slow with this, and my board gets laggy if I go too fast. Okay, so for the next one, we are looking for the cosine of theta that has a ratio of 1/2. So it's simply going to be the inverse. And again, that's not an exponent. So we're looking for the inverse of 1/2 and find out what that missing angle is. All right, so we bring up our calculator. I wonder if I can move it over. Oh, I can. Okay, so second cosine. You can type it in as a fraction. I'm just going to put in 0.5, and it spits out 60. So the answer to this one is 60 degrees. Now, let me show you something. If you're not getting these right answers, one thing you always want to check is make sure that your mode is not in radians, but in degrees. So if you're getting wacky answers, a lot of times it's because your calculator is in radians and not in degrees. And there's a time that we're going to have it in radians, but not right now. Okay, next one. Tell you what. Go ahead and pause the video. Think about that and go ahead and try this one on your own. And then I will check in with you. All right. Hopefully you guys got, oops, negative. Is it negative? No? I think it's positive. I'm going to double check. Caught my own error. It's negative. And when you're typing those in there, remember, if it's like the leading character inside of these parentheses, your calculator wants the negative sign and not the subtract sign. Okay? So this is negative 30. All right. Okay, now they're getting a little bit more complex because we're going to be solving these equations, and always pay attention to how they want it. They're going to want it in forms of radians because to them that's the simplest form, because any pi, remember, is 3.14 on and on and on and on, so that's irrational. So anytime you have to round something, it's not really precise or the simplest form. Okay, so on this one, remember, you want to treat this angle as if it's the unknown, or it's the x. So whenever you're solving any equation, you're trying to kind of work PEMDAS backwards. So, oh, am I lagging again? Lagging. So when you're solving any equation, you're kind of working PEMDAS backwards. So subtraction and addition is what you would get rid of first. Okay, so again, you're going to be treating this this angle as if it's the unknown. So this is the one you're wanting to isolate. So first I need to get rid of this negative 15. So I would add 15 to both sides. On this side, you're going to add 15. And that's going to give me 15. This is like times the tangent of theta equals, we have 15 on this side. Okay, so what's the next thing that we need to do here, you think? Right, we have to divide by 15 on both sides, because again, we are trying to isolate this tangent of theta. Okay, so this cancels out, and so now we're left with, I'm going to write it over here, the tangent of theta equals 1. All right, now the last thing that we have to do is undo this tangent. So what we know is, with our new tools in the toolbox, is we can do the arc tangent of, if we did that on both sides, like it would look like this. Tangent, arc, sine, but you'd have to do that on this side. I'm not going to be writing that out all the time. And so this one, when I do this one, so we would be left with theta equals 1 times the arc tangent. Okay, so we go down here, we grab our handy dandy calculator, we turn it on, we can clear out some stuff. So we're going to do second tangent 1, close the parenthesis, and that angle that we were looking for is 45 degrees. But always check, because IXL will, you put that in there and they're looking for a radian, that's really going to not make you too happy. So if you want, you can go ahead and convert that like I showed you before, or if you have your little cheat sheet unit circle here, we can look at a 45-degree angle and see that in terms of radians, it's pi over 4. So the answer in terms of radians is pi over 4. You can also think about that as it's like 1, oops, let's do a different color. It's kind of like 1/4 of a pi, but you know, IXL doesn't want that in there. Okay, so that's the answer to this one. All right, I want you guys to, hang on, go ahead and pause the video and try numbers 6 and 5 on your own, and then I will come back and we'll see what we have. All right, so what you would have done first is get rid of the addition or subtraction. So I subtracted 12 from both sides. Then here I went after the multiplication division, and I divided both sides by 6. And that gives us on this side a -1/2. Now, then we take the arc sine, which undoes this, and that's going to give us the angle that we're looking for. So the arc sine of -1/2, which you could have typed in as 0.5 if you wanted to, -0.5. that would have spit out 120 degrees. So if you wanted to, you could then set up this unit multiplier and turn it into radians, like I've showed you before. Or you could have, let's see, turn it on. Let's see. Where are we there? Hang on. This is what I meant to get. I could have taken that 120 degrees and looked on my unit circle here, and I could have seen that that is also 2/3 pi, if you wanted to do it that way. But if you did do it this way, where you're multiplying it out, and remember the kind of a shortcut, if you're I don't know, if your brain is tired or whatever, and you just wanted to do 120 times, well, on your numerator, it would have been 120 pi, and then you would have had on the denominator divided by 180. Okay, you could have put that in there, and then remember, you can tell the calculator, turn it into a fraction, and that would have given you your 2/3 pi. So there are different ways of doing that, because remember, on an ACT, you're not going to have that unit circle hanging around all the time. Okay? So go ahead and try this next one. Let me move this little guy. Now, remember that we treat these sine of theta as variables like you would in x. So here, if that was an x there, you would have say, I have -17 of these, and on this side, you have a +3 of these. So remember, as in any other equation, you want to get like terms together. Okay, so that's my little hint for you. So go ahead, pause the video, see if you can figure that one out. All right, so first thing I did is I moved this 17 sine of theta to be on the other side along with the 3. So kind of think about combining like terms there. I know this came out a little sloppy. Sorry about that. And then that gave me 20 sine of theta equals 20 left over here. Then I divided by 20 here. I didn't show all that because I shouldn't have to by now. And 20 divided by 20 is 1. This one's gone. So now the last thing we have to get rid of is this sine, and we use the arc sine to get rid of it. And so the arc sine of 1 is a 90-degree angle, which we wanted it in terms of degrees, so we're good on that one. Okay, the last one here. This is a little bit different because we've been working with these ratios, which are on our calculator, but these reciprocal functions are not on our calculator. So the way that you're going to use the cosecant, the secant, or the cotangent is going to be like this. Okay, so to undo this cosecant, we're going to use, cosecant is the reciprocal of sine here. So that's the one that we're going to have to use. So we're going to use the arc sine. But then when you get to put the number in, this is what you're going to write as a reciprocal, because the cosecant is the reciprocal of sine. So this is a -2, so we're going to write it as a reciprocal. So it's going to be a -1/2. Or you could put it in as a -0.5 if you want, and you'll get the same thing. Okay, so to get that in a calculator, we're going to do, this is going to be easier to put in because it's just less typing for the calculator, but I'll just do it anyway. So the arc sine, and I'm going to put in a -1 divided by 2, and that gives me a -30. Okay, and if I did arc sine of -0.5, -30. So it's the same thing. Okay, so you could take that negative 30 and you could use the unit multipliers to convert it into radians. Or if you're familiar with your unit circle here, you can see that a positive 30 degrees away from 0 is pi over 6. So if you go that same distance, if you follow this line down, see this is a negative 30 degrees away. So these kind of are both 30 degrees away from this x-axis. Now, just don't make a mistake where you would call it 11 over 6, 11 pi over 6, because it's not. That's, if it were a positive angle, you would get to it that way. But negative, it's going to be a negative pi over 6. So our answer is going to be a negative pi over 6. That's what they want. And hope all that makes sense to you. If it doesn't, or if you found some errors, go ahead and hit me up and let me know. And until next time, hope you guys are doing well and you kind of rock this IXL solving trig equations. See ya.